All right, so a lot of the tests that we're having soon on communications is about writing equations. Writing equations for situations. A lot of it. I kind of went through, and I'm actually the one who made the review worksheet this time, and so it really made me focus on, really being careful about, what to put on there, and it was all about writing equations. Not everything, but lots and lots of different equations. So here's a picture. If I drew that right away, you'd know what kind of an equation to use. What kind? Exponential. Now, how steep that line is and stuff will make a difference, but this is, at least you should know it's exponential. What starts going, then it levels off like this at like that. That's not the exponential. You know what it's called? Yeah, it's got that L over thing. Yep. Do you know what this is called? It's called the basic logistic function. All right. That's the kind where they 2 points and it levels off at and it looks like this: y equals 50 over 1 plus ab to this again. And you have to find a, and then you have to find b. Remember this? All right. So if we use this example, I want to do one more of these because these are probably the hardest thing that you have to do as far as like lots of algebraic manipulation and stuff. So let's 5, and this one's at 6 comma 20, or maybe make it 8 comma 20. So if you were going to have to write an equation, your first step is to put in here, and then it'll help you figure out what A is. Don't say calculator because it looks like there's going to be no calcs allowed on the test. So that means you can leave your answers like, let's say it comes out to 73/5. You can leave it like that. So just figure out A right now. X is 0, y is 5, 0, 5. 5 equals 50 over 1 plus a, and then the b to the 0 to 1. So that just makes it disappear. Got to be able to handle it like multiply situation. I'm going to go this times this. 5 times 1 plus a. You put those in parentheses. And then 50 times 1 is 50. There we go. Now, you could multiply this thing out and multiply that 5 in there, but it's actually way easier to just divide by 5 right now. Because now 5 is gone, see? And 50 divided by 5 comes out to something real nice, comes out to 10. So 1 plus a is 10, so then I subtract 1 from both sides, and I got a equals 9. Yay! Raise your hand if you got a equals 9. Okay, good. So that's the easy part. So now if I put a 9 right here, now I'm going to put in the x and the y as the other point. So, technical difficulties with my board. Sorry about that. Hold on a second here. There we go. Okay. I don't know why that just happened. I'm trying to just delete this 5 and it doesn't want to go. Okay, there. Now, try putting in. This is the hard part. This is where you're going to earn your A. That's X. That's Y. Man, solve for B. Yes, B will be an ugly number. It'll be like 7/8 minus 1 to the power of 1/20th or something like that, or 1/8. But you can leave it that way. All right, so if X is 8 and 20, I go E equals 50 over 1 plus 9b to the 8th. Then this part's in parentheses, so you'd be going 20. This is 1 plus ab to the 8th equals 50. You're looking 5. There. Then I'm going to divide by 20 on both sides. And let's cancels, and I have 1 plus AB to the 8th is equal to 50/20ths, which reduces to 5 halves. Then I'm going to subtract 1 from both sides. Okay, hold on. What was your question? I am solving for A, yes. Oh, yes, there should be a 9 right there. Sorry, you're right. I think maybe that was a 9, and I thought it was an A. Sorry about that. This is a 9, because we figured out A is not. Okay, and then I'm subtracting 1 from both sides. Now it's 9b to the 8th equals 5 halves minus 1. Could I actually do 5 halves and get 2.5 and then subtract 1 and get 1.5? Yep, you can do that. But you're not going to have a calculator, so if the numbers get really hard, don't try. Divide by 9, divide by 9. Where it starts to get really complicated looking. And then I'm going to put it all to the power of 1/8. Like that. So I just figured out that B is 5 over 2 minus 1 all over 9 to the 1/8. Now the final answer is to rewrite the equation from the beginning. Y equals, and then it's the limit to growth, which I think we said was 50, over 1 plus A, which we said was 9, and B, which is this ugly thing. And then don't forget that it's to the x power. That's probably going to be the most common mistake. I'll keep on pounding in that that's important, and hopefully you remember. And remember, this is to the 1/8, so that goes right by the x. You could put that as x over 8, but 1/8 x is just a way to do it too. Okay, it's ugly, but that's your equation, and it doesn't have any issues in it because we never actually used the calculator to get a decimal. So one problem is if you had done rounding early in the problem, when you have an exponential and you put something to like the 1/8 power, it really magnifies any rounding that you did. So it's best not to round exact answer. Yes. Yes, you will have ugly things like I have right here. Could I simplify this? Yes, I could, but I don't have to. Like that right there, that would be 2.5 minus 1, which would be 1.5, but I didn't have to do that. I can leave it that way. Okay, because 1.5 over 9 wouldn't round nice anywhere, or wouldn't come out to a nice number anyways. All right, so that's another typical kind of a problem. I want to talk about another real-world situation where you would use, where you'd have to write an equation. Let's say it's the number of, what am I going to go with? Walleyes in Lake Mille Lacs. They're worried about the number of walleyes because just set the limit so that it's like when you catch walleyes in Lake Mille Lacs, you have to throw almost all of them back. There's a certain slot limit where they'll allow you to have like one walleye. If it's between like 18 and 23 inches, they'll let you keep one because they want to let the fishery kind of recover. Because basically, the population has been dwindling. What does that mean? That's decay. Hopefully you know decay kind of looks like that for a graph. All right, so if the population of walleyes right now, let's say 1,000 walleyes, and it's going down by, let's say, 6% every year, then you should be able to write an equation for that. Don't overthink this one. You know the starting value. You know the decay rate, 6%. So you should say, for this equation, 150,000 they're starting. And then you always have this b to the power of x. But I told you something that would tell you, I told you it was going down 6%. So you replace the b with 6%. Minus 0.06. Do you notice what I did there? I took 1 because if I multiply this by 1, it'll bring back my whole population it was. Then I gotta subtract off 6%. Okay, so if you'd have just jumped right to 0.9, that'd have been a great way to do it too. But what you don't want to think is, oh, I just put 0.06 in here. If you multiply something by 0.06, you're taking away 94% population. That's not what we want, right? We want to only take away 6%, so we take minus 0.06. All right, I'm going to give you another one like that. Now that I did one for practice, next one should be easy. Let's, instead of talking about walleyes, let's go with loons. Loons, they're also a kind of species we watch really carefully because in Minnesota, the loon population is it's important to us because they're our state bird. You know, a lot of part of going up north and being on the lake is hearing the loon call and stuff. So anyway, the loons have been dying, and it's not here in Minnesota. It's when they're migrating. And a lot of them go to a lake where there is, it's weird, there's this fish that they really like to eat. And they dive down, they swim down to catch the fish. And these fish have got there's something killing these fish, and it's giving the fish some kind of an infection or something. And then the loons are eating these fish, and then they get the infection and they die. So they found like 300 dead loons on this lake that's in one of the states that the loons migrate through. And so all these loons are landing on this lake. They go down, they see, ooh, these fish look, they love this fish. Go down and eat the fish. All it takes is eat one. They get sick, they die. So we're losing our loon population based on it. So same idea. And we're not going to lose them all. They don't all migrate through that, but the ones that migrate through that spot will. Situation. 100,000 loons. And let's make this one trickier. Let's say that it's only dropping our population by 0.1%. I could see them making it harder than a normal problem. So it's 100,000 loons, but the population is dropping by 0.1%. I didn't say 1%. 0.1% every year. All right, so generally, I hope you know it's going like this. And it started at 100,000. 0, 0, 0. Okay, this is 100,000, but that's our loon population. And it's going down by 1%. So y equals 100,000. And then I go, my b is not 0.1, it's 1 minus 0.001. How many got that right? Okay, good. Be careful with that decimal, because that would have been totally different, of course. That 1%, 0.1%. All right. Then the last thing I don't have is a what? To the x in the exponent, because that makes it exponential. And it's exponential decay at this point. And the last thing we'll talk about today is if I asked you to write limits for this puppy. The limits for the n. Try to do it without me, and I'll tell you if you did it right. Your limits always start with lim of the function as x goes to. So there's the right limit and there's the left limit. Both start the same way. The right limit means way over there, which would mean x goes to infinity, and when I get there, if I ever could get to infinity, it would get to 0. But I never can get to infinity, so it won't ever get to 0. So I say it approaches 0. Okay, on the left end, it's way over there, which means negative infinity. And then, will it be when I get there? Sure, so it would be positive infinity. Raise your hand if you had those right. Okay, good. That should be an easy kind of problem. Yes? Cyclogistic? That's a good question. The only time you would take a population question and do basic logistics with it, and again, those look like this, is if they tell you a limit to growth. As soon as they tell you a limit to growth, then boom, it's, and where they've said that the limit is 100 loons or whatever, you're only going to use that kind if they tell you the limit to growth. Okay, I think that's enough practice on Precalc for now. I think we're on good track then to know everything we need to know by our test. So for today, the rest of the day, for my other classes too, all we're doing here is we're going to get the answers to you for the review packets you did already, and then hand you another small packet on financial type problems that could be on the MCA. All right, that's all we got for the video then.